All right, let's take a look at an example. I think this is really where you can start to understand what's going on with these. So we've got this position time graph, and we are going to be asked to find 5 things. The total distance that this object traveled, the total displacement, the average speed from 0 to 4 seconds, and the average velocities both from 6 to 8 seconds, as well as for the entire motion of whatever this object happens to be. So if we remember that the slope of this, actually, I'm getting ahead of myself. If we want to find the total distance, I can just read this graph. So if you look here to go from -4 to +4, that is a change of 8. So that object went 8 meters forward because it went from -4 to +4. From 4 to 6 seconds, it doesn't go anywhere because its position is still 4 meters the entire time. So there is no change. There's no distance traveled. And the last is from 4 to 0. That last segment from 6 to 8, it goes backwards 4 steps. Now to find the total distance, distance is a scalar quantity. I can ignore all those positives and negatives and just add up 8, 0, and 4 and determine that this object moved a total distance of 12 meters. For part B, the total displacement, well, I can use those same 3 values, but because displacement is a vector quantity and direction matters, I need to include my positives and negatives. +8 plus 0 plus -4 gives me a total displacement of +4 meters. Just to again show you very quickly, we could have also simply taken the final position, which was 0 because we were on the x-axis, and subtracted the initial starting position, which was at -4, and that would have also given us +4. It doesn't matter, whichever you feel most comfortable with should get you the same answer. Now we get into speeds and average velocities. This is where we have to remember that the slope of a position time graph gives us the rate at which the object was moving. So the average speed from 0 to 4 seconds, what we should be able to, again, just take the slope of that. Really, the slope is the velocity, but because we just have the one slope there, it's essentially speed because we didn't change our direction at any point. So find the slope of that point. Let's use the first point, which is 0, -4, and the end of that at 4 seconds, which is 4, 4. And I can use my slope equation, y2 minus y1 over x2 minus x1 gives me 8 over 4, which reduces to 2. So the object's average speed for the first 4 seconds was 2 meters per second, quite simply because that was the slope of the line over the first 4 seconds. Part D, I'm going to do the same thing, but for 6 to 8, I'm going to use the coordinates, but it's still the slope, the coordinates from 6 to 8. So those points at either end are 6, 4 for the first point and 8, 0 for the second. So if I go ahead and I use my slope equation, y2 minus y1 over x2 minus x1, that gives me -4 over 2, which reduces to -2 meters per second. If that was a speed, I would just say 2 meters per second, but I was asked for the average velocity. I must denote that that object was moving backwards, hence the -2 meters per second. Now, for part E, the average velocity for the entire motion. There's really 2 ways we can go about this. It depends what you're most comfortable with. I will show you both. One of them is to just use the equation, right? We have the equation for the average velocity, which is the displacement divided by the time. Unfortunately, I erased the answer, but if you use our displacements that you see up top, 8 plus 0 minus 4 gives me +4. As we discovered in part B, the displacement is +4 in total for the trip. The whole trip took 8 seconds, so I can just use that equation to get about half a meter per second in the positive direction. I actually do it a little bit differently, especially if it's a really involved graph, but it requires one extra step, so I will show it to you and you can determine whether it's something that you like. Now, I can also just find the slope. The problem is I have 3 different slopes over the course of this journey. I have a positive slope, then 0 slope, and then negative slope. You can use a little graphical trick, and that's why I like these motion graphs. I can draw my own line connecting the starting to the ending points, right? That is not anything that represents what the actual object did in its motion. It just graphically shows us what the slope is between the starting and ending positions. And if I just use those points and I go ahead and calculate the slope, you'll find that you still get positive 0.5 meters per second. Either one of those is fine. This is a fairly simple graph, so I might honestly just add up the 8, the 0, and the -4 and divide by the time. But if you have a graph that has a lot of points, it goes up and down, and it's a very long graph over a long amount of time, I like to save myself some trouble and just draw a straight line from your start to your end point and calculate the slope. Again, either one is acceptable. It's whatever you feel most comfortable with.